Welcome to Lesson 3. Before we begin, I want to show you a photo. That's the window where I'm recording these videos. You can see there is a street running past and two dogs monitoring what happens on that street. Oscar on the right, Felix on the left. Oscar's not interested in maths and it tends to send him to sleep. Unfortunately, he has a snoring problem. So every now and then you might hear Oscar snoring. Okay, to the maths. In these early lessons, I have to keep emphasising the fact that I'm deliberately keeping this as simple as possible. However, I'm inserting ideas and they will generate your keys to understanding the difficult maths in later lessons. It's important to ensure that certain ideas are internalised before other concepts are introduced. Otherwise, the new material will not have a secure foundation. We want the underlying links in our theory to be both strong and familiar, so they operate on the subconscious level. This limits any possibility of stress, which can hinder or block progress. The two main ways of doing so are simplicity and repetition. If you watched lessons 1 and 2, welcome back. If you didn't, I suggest you go and watch them before viewing this one. It's important to follow and think about the whole sequence. Think back to the previous lesson. I tried to develop the realization that a number should always be viewed in a context. I did this because that context is what lifts things from simple numeracy and makes them relevant to the mathematics. Notice numbers are not mathematics, but they are relevant. So today we'll look at some mathematics. There will be numbers, but do not focus on them. Concentrate on what is bringing the numbers in. We will now go on to develop our mathematical structure. Whenever you learn something in maths, you are doing one of three things. The first, you are changing a value in a specific way, determined by the context that makes that change relevant. The second, you are using given information to lead you to a missing or unknown value. And thirdly, you are illustrating all possibilities that, while being unique or different, still share the same important structural or conceptual features. So when you're doing maths, we are going to break it down into one of three things. This can be summarised in the following diagram. What people generally see as maths is really three different activities. They are separate, they are distinct, but they are closely related. Case 1, change the given value. Case 2, find the missing value. Case 3, illustrate all possibilities like this. So that is maths, three activities. and the reasons for changing the given value become the basic theory for different maths topics. Now, elaborating on type 1. Without a context, this becomes numeracy and memory, and makes everything an automatic reflex, which can save time and effort. But keeping a context in mind stimulates understanding, which makes things even easier. A simple example. Having an original value changed in a consistent way, such as what happens when you add 2. So there is what you are changing. The reason you are changing things is you want to add 2. This leads to 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, etc. Now, in real life, there would be a reason for doing this. And that reason would be the context that makes the numbers relevant. I deliberately did not write 2 plus 1 equals 3, which is a correct statement and often done. I wanted to establish a consistent structure based on an original value being changed leads to a new value. So notice I am putting a structure on what I am doing. And I did this because it matches the emphasis I have been putting on things. Saying maths is about consistent changes makes everything easier. It collapses a lot of complexity into a few simple thought patterns. The being changed part represents what we are investigating. In this case, the result of adding 2. Why are we changing anything? Maybe we're investigating the relationship between children, parents, and family size. So the number of children can be changed into the number of seats required for a family. A practical context might be organising a meeting with the family. So note 1. Once things are practical, we have a number of possible cases, depending upon the number of children. Secondly, there are many different possible scenarios or settings for the meeting. But independent of all of those scenarios, there is a structure. The practical situations lift things from numeracy to mathematics and allow many different maths problems to be generated from one simple relationship. Our scenario could be a school organising a fundraising event, or it could be an end-of-year presentation assembly. Both aspects of the word school generate a reason for changing a number of students into a number of seats required. Some mathematical terminology is relevant here. The concepts we start and finish with, in this case, children and seats, are called variables, because the numbers relevant to each can be different for different families. Now that will do for this lesson. We've introduced some new ideas and that gives you something to think about. We'll expand on all of this next time. I hope to see you then.